Okay, now we're going to be looking at problems where we've got two polar graphs. So if you look at this problem, it says we want to find the area of the region inside the cardioid 2 plus 2 cosine theta, and I already sketched it in pink, and outside the circle r equals 3. And again, we can look at both of these on your graphing calculator. So I'm in polar mode, and I've typed into my r equals screen. So again, anytime you want to look at the graphs, make sure that you're in that particular mode. Let's just make sure, I think I want to look at just make this to be 2 pi, and I should be able to see it. So there's my cardioid, and there's my circle. So let's figure out what region we're looking at. So inside the cardioid and outside the circle. So that's this region right here. So this is that shaded region. But notice this part here and the bottom part, there's going to be the same. So I'm just going to find this region right here, and then I'm just going to double my answer and do it by symmetry. So very similar to how we did before when you had two functions in rectangular mode. First thing we need to find is that point of intersection. So this is the piece that I'm going to need to find first, because that's my angle. So we need to find when is 2 plus 2 cosine theta equal to 3. So this one, if you want, you can solve by hand. You end up with 2 cosine theta equals 1, cosine theta equals 1/2. And you're always looking for the first time this happens, right? And where theta is positive. So it actually happens at pi thirds. Now, the other way you can do this, you can also go ahead and do this on the calculator. So remember, we can always solve an equation on the calculator. So this is the equation I'm trying to solve. Notice there's only one variable. There is no intersection feature in polar mode, so we're going to solve this in function mode. So we're going to go back to mode, go back to function, and type in our two equations there, which is 2 plus 2 cosine, and the other equation is 3, and we're trying to find the first angle, which in this case is x, where they intersect. So you want to make sure, go to your window, my x is my theta, so set that up to be 0. And as long as I can see 3 for the y, that should be fine. So let's look at the graph. So it has converted our polar equation to function mode. And then there's r equals 3, so I'm looking for that intersection right there. So I'm going to do second trace, intersect. There's only enter, enter, and just be somewhere by that point of intersection. Press enter, and you're going to get 1.047 something. And I believe that's the same as pi thirds. I'm going to go ahead and store this answer so I can use it going forward. So I'm going to store it as A. So this is 1.047, and I'm going to label it on my paper as A. Okay. Remember your angles. Go start from the origin and go out. So I would draw this angle in. So there's theta equals A. Now, I also need this angle because that's where my shaded region starts, right? This is where my shaded region ends. This is where my shaded region starts. So I also need this angle. Now, it looks like this is theta equals 0, but be very careful. It doesn't always have to be theta equals 0. Theta equals 0 could be over here. So I would just double check on your calculator. I'm going to go back to my polar mode. And let's make sure, again, I have to be able to look at my x's, so -5. And I just want to look at the cardioid, so I'm going to turn this one off. So I want to figure out what that angle is right there and use the trace feature. And yes, that is theta equals 0. So I would just double check. So if I integrate the pink cardioid from 0 to A, you're going to get all of this. Okay? But I only want this little shaded region here. So what you have to do is actually subtract off this blue region right here. So I'm going to integrate the cardioid from 0 to A, right? 0 to A, which is pi thirds of the cardioid, which is 2 plus 2 cosine theta squared. And that will give me all of this, but I need to subtract off this blue region. So I'm going to subtract off the circle from the same bounds, right? 0 to A of r squared d theta. and that will give me this region. But since I'm doing it by symmetry to get the bottom one, we just need to multiply by 2. And go ahead and punch this into your calculator, and you should get a numerical value of 4.6526.